Hi, everyone. I'm Chad Gray. I'm a software engineer at Dell Technologies. And recently I've been working as an engineering product owner on APEX Navigator. So thank you, Pratish, for doing the introduction to APEX Navigator. It's been a really exciting product to work on. And we delivered APEX Navigator to simplify storage management and to really make that block storage for AWS available and easier to get usage of. So Pratish touched on the five major focus areas we had with APEX Navigator, including security, deployment, management, monitoring, and mobility. To get going with all these great features and these focus areas, it really starts with getting access to the consumers and the customers' AWS environment. And so that's what I'm going to start with today, is talking about how APEX Navigator accesses the customer's AWS account. So in the next 10 minutes, I'm going to touch on how our solution there, how to connect an AWS account from APEX Navigator's UI, how to audit that access and account management. Vendor solutions are being adopted widely, and they're being adopted because they enhance operations. And it's very important for vendors to take security first and to access these environments in a secure manner. You'll find some vendors ask for shared credentials or a service account and a credential to access the environment. And there's some challenges with this, namely around credential management and the communication loop that's needed between the vendor and the consumer with the management there. And with this approach, the vendor isn't always able to invalidate the credentials if needed. With APEX Navigator, we look to solve this by leveraging AWS roles and policies, which means there's no AWS access keys that need to be exchanged. And Dell or the consumer can disable this access at any time. So with that, I want to look at this component to just provide a high-level view of what the configuration is needed and how we're accessing the AWS accounts. On the right, you'll see the consumer's AWS account, and what's needed is to create an AWS role. With that AWS role is a trust policy, and what the trust policy does is it explicitly says who can access or who can assume this role, and that's an AWS IAM entity, or in the trust policy referred to as a principal. This trust policy is automatically generated, unique to the consumer and the account by APEX Navigator, and we'll give the policy to the customer to go install with their role. Next is a permission policy. This covers all the AWS actions and resources that are allowed by the AWS role. With this configuration, it grants APEX Navigator trust to access the AWS account and stand up the resources necessary to run the Dell storage offers. We approached this solution because we wanted to provide something simple to configure and secure for our customers. With this context, I'm going to jump over to the demo to show how to connect an AWS account.
Can I have a question here?
Oh, yeah, absolutely.
So if you have this your SaaS application, can you federate it with your Active Directory or some Airbag or LDAP or wherever is there?
Oh, great. I'm happy you touched on that. And I actually jumped past that into the access to the AWS account, but you're right. Our users will have a Dell Premier account, which is registered with their company, and they will configure and federate their login with their identity provider. Mm-hmm. And so every user logging into APEX Navigator is verified and logged in with their identity provider.
So onboarding will look like this. So my standard onboarding procedure with a corporation would mean the identity provider will create the identity in the company, and then I link this identity with the Dell Premier account.
Yes. So that identity gives you SSO across Dell APEX and Cloud IQ.
All right. Okay. Thank you.
And Premier. Yes. All right, and what you're viewing here is the APEX Management Console, where you'll access APEX Navigator and centrally available to you. And the way to get here is go to Manage Storage, and then we'll have our cloud deployments. And we'll this drop down brings you to Managing Cloud Access. Once we click into Manage Cloud Access, this will take us to the Manage or the Cloud Access tab, where you'll find all the AWS accounts that you've connected to APEX Navigator. We want to add and connect a new account. So what we need is that AWS account ID. So we'll go to the AWS Management Console, we'll copy that account ID, we'll come back to Navigator, click Add Account, and this will pop out this side panel. We'll paste in that AWS account ID, we'll click Enter, and what Navigator is doing at this point is it's generating that custom trust policy that we talked about earlier that's unique to this account and the customer logged in. We provide the permission policy that we also discussed, and you can we provide detailed instructions for how to install this in AWS with this dropdown. We allow you to view the policy we're asking you to install with all the necessary permissions and actions that are required. And at this point, we also provide the trust policy, which you can view. And so we'll copy this policy, and we're going to go over to the AWS Management Console. And we need to navigate to the IAM dashboard roles, which is where we're going to go create our role. The first step is to select the trusted entity type, which is custom trust policy. We'll paste that trust policy that we got from Navigator and move on to the next step. Here, we need to add a permission policy. I earlier already added one, so we're going to search for it and select it and go to the next step. The third step in creating a role is to name it and to review the policies that we created. And so if I was using APEX Navigator, I would take these two policies to my AWS administrator who's likely overseeing this environment and ask them to create this role for me. And then what is needed is that AWS Role ARN, which is the unique identifier to that role. And so once you create the role, you click in to view the details, and you would select that role ARN or AWS resource name, and that's the last piece of information that's needed to connect your account to APEX Navigator. So switch back to APEX Navigator, we paste in this role ARN, and at this point we click Grant Access, and Navigator will verify that it has access to the account, and that account will now be available to you to deploy your storage and leverage APEX's features.
I have a question
Yes.
regarding the setup process. Do you also have infrastructure as code examples for setting this all up as well? If my team uses CloudFormation or Terraform or Pulumi or something, can they just go to a GitHub repo that has this setup process and run through that instead?
Yeah, thank you for bringing that up. I intended to talk about, while I'm showing this in the UI, all of this is available through our API. And I believe, Pratish, you had touched on that we just released a Terraform provider for APEX.
Okay.
And so with that, you should be able to write all the tooling to automate this.
Okay, excellent. Yes. Thank you.
Thanks. And also just to want to touch on, once you kick off these AWS account management activities and events in Navigator, you can find, you can view them from the Jobs tab. To check on their success. The generate trust policy is a relatively quick job. It just takes 4 seconds to kick off and create that custom trust policy for you. But you can view it here to see who triggered it and ran it. Also, we provide the APEX audit log. So if you filter by internal and onboarding, this will bring up a detailed audit of who kicked off these account management events with what resources and when, which gives you visibility into what's happening with your resources. And the last piece I want to look at on audit is we've looked at how to audit this in APEX Navigator. Now the customer can also go to their AWS account and look at CloudTrail and see exactly what APEX Navigator is doing in their account. We leverage the Assume Role API to access the account, and with the Assume Role API call, we tag the sessions that we open, the temporary sessions. So you'll see here we have the APEX job name and APEX job ID, and so you can associate all the activity that you're doing in Navigator, such as a system deployment with the actual API calls that are taking place in your account. And you can manage that job from Navigator. We also pass the source identity of the user that's federated with your custom or company identity, so that you can see tracing of who triggered this. I'd like to give a quick demo to show how APEX Navigator deploys this in 4 easy steps and automates it and stands it up for you in your AWS environment. Okay, we're back in the APEX console, and under Storage, Cloud Deployments, we'll click on Manage Cloud Deployments. This will bring us up to a table that would display all of our deployed systems. We don't have any just yet, so we're going to deploy a system. We'll click Deploy System. Here is step 1 of 4, where we need to specify the product, cloud, and region we wish to deploy. Right now, we just released an APEX block storage for AWS with Navigator. So that is our product. We'll select that. We'll select the version 4.5.1, and we'll choose a region, which we're only available in the US at this moment. Step 2 is to connect that cloud account. We walked through this in the previous demo of what this looks like to get this added to APEX Navigator. And so we'll just select the one we readied for this deployment. Step 3 gets into the deployment configuration. So these are all the choices that we have with our deployment, and Krithika touched on a lot of these in her presentation, but we'll provide a deployment name. We also will choose our performance tier, which is either balanced or performance optimized. We'll select our minimum usable capacity and minimum IOPS, and these choices change what resources will get deployed into your AWS account to support that. We have the select your availability level, either single AZ or multi-AZ. And we also have the choice to deploy to an existing VPC that we created, or we've already configured and set up, or to create a new VPC. So we'll go ahead and select create a new VPC and let APEX Navigator stand that up for us. We'll put in our IP ranges. And the third configuration item is to name your key pair. So this is setting up an SSH access into the storage instances running in AWS, and that key will get stored in your AWS Secret Manager for you to access later. We'll continue to step 4, where we will review the configuration and move ahead with the deployment. We'll see here that the licensing, we have a free 90-day evaluation license once we stand this up. And it'll also show you the AWS resources that are going to be deployed into your account. So you can go use the pricing calculator to see what this means to you and your company. There's also a few agreements, namely about we're standing up resources in your AWS account, and this is going to incur some cost for you.
All right. Sorry, but that's cost. That's additional cost on top of the cost of Navigator.
Sorry, you would pay. We're giving a free 90-day evaluation license to run the storage in AWS, and then the costs will be the AWS resources that they incur in your account.
And that's a cost I'll have. In addition, after 90 days, I'll pay for Navigator, and I also have the cost in AWS for the extra storage.
Yes.
Got it.
And I'll look to Krithika and Tish make sure that was correct. All right.
Yeah, that's right. Yeah, customer is responsible for the underlying infrastructure, the AWS infrastructure.
Yep. And so once we've kicked off the deployment, we can actually view its progress directly from APEX Navigator. And so if we browse to our running job,
you just confused me. There's APEX, Dell APEX storage.
Yeah, block storage. For
block storage. I'm paying APEX block storage.
Yeah.
And I pay that to Dell. The AWS billing for the underlying infrastructure I'm going to get through AWS. And then if I have Navigator, then that's another deployment that we're not looking at right now.
So APEX Navigator is running in APEX centrally available to you, and so there's no. I guess you don't need to pay, or you don't deploy Navigator.
Right.
You're paying for the storage that you deploy.
So adding to Chad's comment, right? So APEX Navigator is the SaaS console,
Yes,
right?
and
So you don't pay for any so you pay for the APEX Navigator software, you pay for the APEX block storage software, and you still need the underlying hardware, right? That is owned by Amazon or Azure, and
Yep.
you will pay them. So the way you can pay is you can pay for the entire package to Amazon or Azure, and we will actually transact with the hyperscalers. Or you could go pay Amazon for the underlying AWS infrastructure. You could come to Dell and pay for the APEX Navigator and APEX Block Storage software.
am I looking at APEX Block Storage or am I looking at Navigator right now?
You're looking at Navigator.
Navigator.
Okay, sorry, I got lost there.
Oh yes, yes.
Thank you.
Apologies for not watching.
No, I'm sure it was me. I'm sure it was me. Just like, okay, whatever.
Yes, so this is APEX Navigator that we're looking at, and we're looking at the jobs running that's deploying the APEX block storage system in AWS. And so I'll just pause here. You can see these are the steps to deployment. So we pre-validate that the environment is ready, and we can move ahead with the deployment before standing everything up.
Before you move ahead with that, is any of this available on the AWS Marketplace
It
to
is.
purchase or subscription?
It is currently.
Okay,
Yeah,
so I can pay one bill
exactly.
lump sum, so I never see that I'm paying extra for each one. I'm just
Exactly. You can pay for the whole thing to Amazon. Yeah.
When you show me the pricing, are you showing me the Navigator, storage, and AWS costs? Or are you just showing me the Dell pricing?
On that page, where he was deploying, it was initiating a 90-day trial. So the costs that were shown on that deployment page were particularly only for AWS resources.
So you're seeing all of it, but you're not seeing the cost after 90 days. You're only seeing AWS. The cost after 90 days is not being displayed.
And within those 90-day period, then
Got it.
you purchase APEX Block and APEX Navigator to continue.
Okay, thank you.
So let the deployment continue. And we can jump over to AWS to see these instances being stood up. And we elected to create a new VPC, so I'll just jump into AWS's view of that VPC being created. If we click in, we'll see that it's configured with the details that I entered into Navigator. The step is deploying the Secure Connect Gateway, SCG, which enables telemetry from from the APEX block storage back to Cloud IQ. And just gonna, and now it's deploying the storage, and we'll fast forward this. This job takes roughly around 2 hours to complete. And so this is with an automated deployment. And you can see that with these 4 steps and some time, it'll set up and stand up all the storage for you to use, which takes a lot of ease off doing it manually and setting all this up. So with that, we have one more demo with Karithika to highlight the resiliency of APEX block storage. So thank you.
Okay. Hello, everyone. This is Kritika again. I'm a product manager for APEX Block Storage at Dell Technologies. We'll take a quick look at deploying APEX Block Storage. So in the previous session, Chad talked about how do you deploy APEX Block Storage. Right now, we are assuming that the APEX Block Storage cluster has been deployed across multiple availability zones, 3 AZs in this scenario. And we'll talk about what happens, how does the APEX Block Storage cluster react when one of the availability zone goes offline or it is stopped. The storage nodes in that availability zone is stopped. So this specific demonstration was executed with SQL Server 2022, but whatever you are seeing here applies for any application, right? So in this example, you will see that we created an APEX block storage cluster with 6 storage instances, and 2 storage nodes were placed in 3 AZs, right? So 2 in each of the AZs. And what we are going to do is essentially like, make sure that, the system is healthy and things like that. And then we are going to take down the storage node in one of the availability zone. So just to validate, we are making sure the system is healthy, the cluster is healthy. We are verifying the TPMs and things like that. Here, again, to reiterate, it's, the workload here used is SQL Server 2022, but the same thing will be applicable. Whatever you're seeing here will be applicable for any workloads. You can notice that the orders are processing here. You can also see the monitoring and the logs and things like that. Now we are going to forcefully shut down or stop a couple of instances or all the instances in one of the availability zone. We are switching gears to PowerFlex Manager interface. In here, we are going to go ahead and browse for the block volumes, right, using the PowerFlex Manager interface. You can see here that we can view all the PowerFlex Manager volumes, and you can also go verify the SDCs, the storage data clients that we talked about. We are ensuring that all the files that are required are in place. Now we are going back to the PowerFlex Manager, and we are looking at the health statistics, and we are also validating the metadata manager. That's another component which manages and tracks all the data. You can see that the SDS, which is the storage nodes, are all connected. So it is healthy. We are validating that it's healthy now. It's in the connected state. Now we are switching to the AWS portal, and we are ready to start the simulation, right? So essentially 3 availability zones, 2 storage nodes in each of the availability zones. We are going to go ahead and manually stop 2 of the instances in one availability zone. We already stopped one. We are going back again. You can see that the first instance is stopped. We are going to go back and stop the second instance as well in that availability zone. The goal here is essentially to see if the cluster remains healthy and it's able to handle the workload even when one of the AZs completely goes offline, right? You can see that there's a slight dip in the TPM, but the cluster remains online, right? The application is still functional. The cluster remains offline. The best part is once a AZ goes offline, the rebuild happens, the rebuild kicks in, right? And in this specific example, you can see that the rebuild completes in really quick, in less than 30 seconds. You can see that once those instances were stopped, you can see a momentary dip in the performance. But you can see that the cluster returns to the healthy state. And all it takes is 30 seconds for the rebuild to complete. So it is self-healing. The storage node is self-healing automatically. We started off with 6 nodes and now we have 4, right? Because we turned 2 of them. We stopped 2 of the instances, but you can see that the cluster is healthy. Now what we are going to do is we verified that with storage, with 4 SDSs, the cluster remained healthy. We are going to go back and start both the instances that we forcefully stopped, right? So we are switching back to the AWS portal. We are going to start the instances which we previously stopped. And this is essentially to see how the cluster is essentially taking up the 2 instances that we just restarted and rebalancing the workloads, right? That's essentially what we are trying to provision. So now you can see that all the 6 instances are in a running state. You can see that there was a slight dip in performance, and it's now back to the normal. And that dip was only during the time the rebuild happened. Workload remains constant. And that essentially shows the rebuilding is happening, right? So we do show the process when rebuild happens. And yeah, we are just making sure that all 6 nodes are back up in the cluster and it's in a healthy state.